Okay, so this bottom problem. Yes. Okay, let's try again. So from this bottom problem that we see here, not the one in blue, but the one that we see written here in black, is one of the things we had talked about earlier is a mass spectrometer can probably read what a substance is, its breakdown, its components. But one of the things that you would possibly need to be able to do is explain what that mass spectrometer does and how it does it, and to maybe testify as a witness, because what we see here, we have this crime scene where Orlon has a specific formula of C, one part carbon, 1 part hydrogen, 3 parts nitrogen. So is this maybe some sort of commercial grade rope? Is it one you can find from a hardware store? Is it something that is maybe a fiber in maybe where you might use straps to hold a, per se, that you may hold something down in your semi-trailer? That might be a type of fiber that it is. So what we want to do is we're looking at this. And the breakdown of this fiber is 67.9% carbon, 5.8% hydrogen. Then as you can see, the rest is nitrogen. Okay, so we know what the reading says is this, it has a molar mass of 165.15 grams per mole. So what happens is that number goes up here, 165.15. Then we need to solve for x, but we still need to have a bottom number here. And we get that from our empirical formula, which means we take our amount of carbon, which is just about 68 grams. And, I don't know why I'm writing carbon. So we've got 67.9%, okay, which then gets changed to grams of carbon. So we're just going to change that to moles. And of course, you take your calculator, and we've got 67.9 divided by 12.01. That gives you 5.65. For every mole of carbon, you have 12.01 grams of carbon, which then gives you, again, 5.65. So sometimes, like we had said, is if these numbers don't quite come out very good, maybe you need to extend these numbers out to a couple non-zero digits, and maybe we could close the gap on this. Okay, so there's one number. Then we got 5.7% hydrogen, or 5.7 grams of hydrogen. And by its molar, or not molar mass, but its atomic mass, 1.01 grams of hydrogen, and we would get probably pretty close to the same number, 5.7 divided by 1.01. That gives you 5.64 moles of hydrogen. Okay, so then we still have one element left to deal with, and that's with our nitrogen. So from prior knowledge, since these are in percents, we know that they're going to add together to give you 100%. So therefore, you could take 67.9 plus 5.7, and that gives you 73.6. You do the math in your head saying, what it's 26.4, or you would just hit minus 100, and it says minus 26.4. But that's just two different ways of saying, okay, the rest of that is nitrogen, which is 26.4 grams. We want to change that to moles now too. So we know for every mole of nitrogen, you get 14.01 grams of nitrogen. Okay, 26.4 divided by 14.01. gives you 1.88 moles of nitrogen. Okay? So the carbon and hydrogens are pretty close to 1 to 1. So then what we want to do is divide by our smallest one, which we don't have to do both of those because those are pretty close. So we've got 5.65 divided by 1.88. That comes out to be pretty close to 3, okay? So then what this means then, okay, so 5.65, I'll just write that here, divided by 1.88 comes out to 3, okay? So then we've got one part, but this is just saying what's actually at the crime scene, that molecular formula. So this comes out to 3.
So that top one?
This
does it matter? Sorry.
That top one.
The top, the CHN3, that doesn't really matter to us?
We said this is the formula that was found at the crime scene.
Yeah, so, but like to find anything, we don't need it, right?
Well, you're going to need it for your empirical formula.
Right. We're seeing if this comes out to what we're going to find from our empirical formula. Okay? So, if this comes out to 3, well then this comes out to 3 then as well. So then what this is saying is we've got C3, H3, and N. Okay? Well, it's probably not the same because what you would do is you would add together that atomic mass then, okay? So 12.01 times 3, that gives you 36, okay? And then that would be plus 3.03, then plus your nitrogen, 14.01, that gives you 53.07. So then once we would divide that into there, you would get 3 again. Okay, so then what this is saying is this is not the same substance. Okay, because when you divide this out, like you said, x equals 3. So then what happens is we take this number. Now you got C9, H9, N3. Okay, so we can presume that this is a whole number ratio of that, but it's not the same substance. Okay, and that's the important part about being perhaps a criminologist or a chemist that works for the state attorney's office or something to that extent. All right. So if we're doing all right with this, I think we're doing very well moving forward with what's expected for us tomorrow.
Can we go over one of the questions that are like hydrates?
Okay, just a moment.
See, I did everything else right.
Okay, this is perhaps the best I could do on the spur of the moment. They wanted to see an example of a hydrate. So how would this be different than what you may have done in the lab? Well, it might have said something like if you had weighed your crucible and it came out to let's see here, you would weigh it and well, then you're going to subtract the 2, but I'm just trying to figure out how that would actually be worded. And that is, maybe the crucible weighs 18 or 10 grams, then you get a total of 18, because what happened is you added 8 grams of hydrate to this lead to acetate, okay? So then altogether it was 18 grams, but the crucible was 10. So then you subtract that, and that's where that number of 8 grams of substance is in this crucible. So then after heating up like you did in your activity, maybe after 3 trials, that number keeps getting smaller and smaller and smaller when you are subtracting them. Okay, so then what's the difference? What does it mean to make an anhydride then? Just tell me. Yes, you're removing the water from that. Okay? So then what would you do with this 8 grams of this lead to acetate, which here's your formula for that?
You minus 8, you minus 114 from 8, right? What to get the 114, is that what you're asking? To get the anhydride, what would you do?
Okay? So remember, this is everything up here. Okay? So if this is the anhydride then, okay, well then how much of the hydrate did you have? Because you're going to subtract them, like you said, that is correct. Okay, so then if this is what you boiled out here, because this has the water and the lead to acetate in there. So then upon heating this, that's going to give you what your anhydride is. Okay? So then once you subtract them, I would be led to believe we get what from that? 6.86 grams. Okay?
Ratio? No, of the anhydride of water.
No. 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 Of this. Okay? So then what you're going to do, so this is lead acetate. So we'll just go ahead and abbreviate that. Okay? So how do we cancel out grams in our next step? Okay? Okay, so once you add all these together, this is 207. So 207. So then looks to me like we've got 4 carbons, so that's 48. Okay, and then we've got, okay, so we have 4 oxygens then, times 16 would give you 64, and then looks to me like we've got 6 of those hydrogens, and upon adding all that together, okay, 207 plus 48 plus 60, oops, not 67, 64 plus 6, that gives us around 325 grams per mole. 325 grams of lead acetate gives you a mole of lead acetate. Okay? Okay, so let's go ahead and divide that out. 6.86
Yeah, 0.02.
divided by 325. You get 0.02. We're going to extend it out a little bit. That's still correct. 0.0211. And we're just going to put another digit on there. So then, again, this is your anhydride right here. Okay? So then, if they removed 1.16 grams, that must mean that 1.14, I said 6. If they removed that 1.14 grams, that must be what substance?
Water.
That would be your water now. Because remember, this had everything in it, had the lead acetate and the water. So then if they removed 1.14 grams of this water to make the anhydride, which means a substance without water in it, that is what we found here, which means 1.14 grams of water now. See, once what we get for every mole of H2O, you get 18.02 grams of H2O. And then hopefully these come out to be really good numbers. 1.14 divided by 18.02. Okay, so 0.0632. Well, 3233. We'll see once how that comes out. So moles of water. Okay. Now we're on to our final step. Okay, which means the moles of the water goes on top. Okay, so 0.0632 over 0.0211. Okay, so that must mean that that is the formula for your hydrate. You come out with the number 3. So it'd be lead acetate with a multiplication sign, or X, just meaning 3.
Or like, how would you answer? Circle that.
Well, you would say you have PbCH3COO. Something like that. Because that's how they're written on the hydrate bottles. It probably has a dot. You could probably just put that on here too. That just means for every 3 moles of water, you have a mole of that lead acetate. Those moles of water are locked into that molecule. All right. Yes, there's this, and we did our best to try to get real data from that, and I think it's difficult to replicate this in a lab. That's why you could say that anything that goes through the pharmaceutical industry, that's why it costs so much. Whether it's anything from the hand cream that we possibly make in the lab. For those of you who take that course, okay, in about 11 months, okay.
Organic chemistry.
All right. So what we make is a really good product. It might not spread. It probably spreads all right. It starts out really creamy, but it's greasy. But that's what some people may choose to have as some of their desired properties in any hand cream. They want it to spread out very well. Okay. So what was I getting? And whether they want it to smell very well, how well it hydrates, and again, does it feel greasy? Does it not? And in this case, it probably does. So with that, anything that comes to mind that you think, oh gosh. There's very little naming compounds on there, if probably not any. I mean, just because we've spent enough time on that. And we're really doing parts of that when you have some of these problems. You're naming some of these compounds. So with that, is there front row, are we good?
We have some bonus questions.
Second row, are we good? Third row. All right. So, right back. Okay, so a little bit of context on here. As we know, there's a new set of cabinet members going into the President-elect Trump's administration. So Governor Nome will be leaving Pierre, our state capital, to take over as what? for President-elect Trump, and then this 1980 singer known as Bruce Springsteen has a stage name, a nickname, whatever you want to call it, and that is what? Excuse me, and that is what? Okay, so we will catch up to you next time.